Here we have a vector, the vector 3, 4, so we will go over 3 in the x direction, up 4 in the y direction. And I want to talk about what happens if we take an exact copy of that vector and we move it somewhere else in the plane. So let's say we move it to right there. Now what is this new vector? It's an interesting question because clearly it still moves over 3 and up 4. It's an exact copy, so it must move over 3 and up 4, which means that it's pointing in the same direction as our original vector v, this question mark vector. Maybe I'll write it like this. We don't know what it is yet, or what to call it. It's parallel to v, clearly. Because it's an exact copy, it also clearly has the same length. And it clearly has the same components. We moved over 3 and up 4. So this question mark vector has the same direction and the same length, which is the same thing as saying it has the same components as v. And so this new vector must be v. It's no longer a question. This is the vector v. And that's interesting. That tells us that vectors are independent of where they are in the plane. Meaning you could take a vector and translate it around the plane anywhere you want, and it doesn't change the vector. Well, that seems to make a lot of sense, actually, because originally we said vectors are only capturing two pieces of information, direction and length. They're not capturing position. So all they're doing is pointing in a certain direction, and they have a certain length. So they can do that anywhere in the plane. You could take this vector and move it anywhere you want, and it's got the same direction, it has the same length, so it's the same vector. All these vectors are parallel. Again, they're all parallel, they all have the same direction, and they all have the same length, hence they must be the same vector. Maybe I'll write it in orange. These are all v. Okay, so two important takeaways from this video is that vectors are independent of their position in the plane, and vectors are uniquely determined by their components. Meaning if two vectors have the same components, they must be the same vector.